Hey, my name is Kotata Masogomeng, and my team and I will be touching on AI and IoT-enabled hydroponics in rural South Africa, challenges and methods. A study on the intersection of advanced technologies and sustainable farming in sub-Saharan Africa. These are my group members that have also done their research in terms of this project. Background of the study. Study focus, development of hydroponic systems in rural South Africa that are powered by AI and IoT. The study of location. Rural areas in KwaZulu-Natal and the Eastern Cape are the main focus. Key agricultural issues, environmental constraints. These are the traditional farming is challenging due to soil degradation and drought. Rainfall patterns more unpredictable due to climate change. And the economic barriers are modern farming technologies and resources are scarce for subsistence farmers. Additional information, why hydroponics? Water and space are used more efficiently than in conventional farming. Ideal for areas with low soil quality. Technological innovation, using AI and IoT to automate procedures and cut down on human labor. Enhances production forecast, irrigation and crop monitoring, all essential for limited in resources farmers. Historical context, hydroponics has already gained popularity in industrial and urban agriculture. There is little data on how it's utilized in rural environments with limited resources, especially in Africa. The study's contribution. The study's contribution is to offer a scalable structure for using modern technology to improve food security, food quality, and sustainability in developing areas. Methods that were used. These are your co-design approach. The study combined local farmers' traditional knowledge with modern AI and IoT technologies. For testing, 5 distinct rural areas with hydroponic grow tents, equipped automated equipment, and sensors were chosen. The data collection techniques, we have your sensor monitoring, your qualitative research, and your results of automation. Sensor monitoring, sensors were installed in the grow tents to continuously check critical environmental parameters like temperature, humidity, and nutritional levels. Qualitative research, to learn more about how successfully farmers were embracing and utilizing the new system. In-depth interviews, in-person observation, and frequent farm visits were carried out. Results of automation. By greatly reducing manual work, fairing automation gave farmers more time to concentrate on other crucial agricultural duties or even grow their business. For the farmers, this also meant lower labor costs. For going back to the sensor monitoring, we have the examples here in the form of pictures of the sensors on farms that do the monitoring to test, the temperature, humidity, and nutritional levels. The challenges that were faced, we have the technical issues. Despite being designed for automation, AI and IoT systems frequently needed manual troubleshooting due to device failures, power outages, and connectivity issues. Environmental factors, water scarcity, pest infestations, and erratic weather were all problems in rural South Africa. Although hydroponic technique conserved water, it was challenging to regulate temperature in severe weather, such as heat. Adoption barriers, a lot of farmers had trouble adjusting to the new technology. Even though they were educated in traditional methods of farming, they were frequently anxious to completely adopt the new system due to the difficulty of learning how to use it. We have your sustainability, a hybrid approach combining technology with traditional farming knowledge proves more sustainable. Flexibility in technology is crucial. It should adapt to varying environmental and human factors rather than replacing human control. Economic factors. IoT-enabled hydroponic systems, high initial costs, are an obstacle for subsistence farmers. Government or outside funding is essential for widespread use. To make the technology available, the study promotes government collaborations and studies. And lastly, we have the last form of additional information, the traditional versus the modern methods. Traditional methods, the natural fertilizers. These are images of compost heaps or farmers spreading manure, like how it was done back a couple of decades ago. And now, versus the modern methods, the greenhouses, Images of modern greenhouses with automated systems for climate control. In recent years, this has been seen on various farms as a way of a more efficient growth of crops. And on to the last slide of our presentation, we have the last form of traditional methods and modern methods. We have manual labor, images of farmers using hand tools like hoes and sickles, planting or harvesting crops. As you can see in the page, this was the more traditional way of farming before the new technologies were introduced. Moving on to the modern methods, we have machinery, images of tractors, combines, and other agricultural machinery in action. As you can see the contrast here, this ties back to what was stated, that AI and IoT technologies in agriculture is used for lower human use in agriculture and harvesting of crops. That is it from me and my team. Thank you.